So we were doing সুবিধা কতদূর করেছিলাম রে? I think 24, 23 was the last thing that we did. I never put it. Rings with identities in the following conjugations.
Twenty-three.
So this is called Chinese remainder theory, which is of the following form: that if AIs are ideal in a ring R such that R square plus AI is R for all I and AI plus AJ is R, this condition is called co-maximality. Okay, this condition is called co-maximality, which by that we mean if you take I and J are said to be co-maximal if one belongs to I plus J. Okay, that is I plus J equals to R. So this is the statement of Chinese remainder theorem, that if B1 to Bn belongs to R, there exists B belongs to R. I mean, there is a common solution of all these equations. That's what they are trying to say. Okay. So see what they are saying, that AIs are ideal satisfying these conditions, and if B1 to be in R, there exists B such that. So by that they mean if these are equations, mod, I mean, they are saying this basically. Mod AI means, this means B minus BI belongs to AI, okay. So they are saying that, suppose this is, okay, for I running from 1 to n. So according to them, they say that there exists a solution of x. So do you understand the point? There exists a solution of x. I mean, just think about it. Why should such an x exist? I mean, this may happen that there is some x1 minus b1 belongs to AI, and x1 minus x2 b2 belongs to a2. But maybe this x1, it doesn't work when I is 3. I mean, you may have x1 minus b3 not inside a3. Okay. So there is not a guarantee that one such unique, or may not maybe unique, but one such common x will exist such that x minus bi is in AI for all I. But these two conditions actually forces the existence of such an x. Okay. Now, what I am more interested in is the following thing. Yes. See. Now, if, look at it, if these are maximal ideals, then M1, then Mi plus Mj is of course R, because Mi is a maximal ideal, is contained in this ideal Mi plus Mj. Okay. And it is also properly contained in it, huh? Because Mj is not Mi. So this has to be R, right? So the co-maximality condition is satisfied. So is that my Mj is equal to 1? Oh, I mean, oh, that maximality condition is given. So then there exists a common x. Okay, it directly follows from the above proposition. Now this is the thing I was looking for. This map theta. Look at it. The Chinese remainder theorem tells us that this theta is surjective. A1, A2, An are any ideals. Okay, these are any ideals. Then there is a monomorphism from this to this. Okay, let's check whether there is a monomorphism from this to this or not. Let's check. So theta is the natural map. So theta is defined like this. Okay, let's not define theta directly. Let's take phi first from R to. So if phi x is 0, so x belongs to car phi x is 0. This implies x plus a1 x plus an is 0. That means x plus ai is 0 plus ai, which means x belongs to ai for all I, right? Which means x belongs to intersection ai, right? Right? This implies car phi is contained in intersection ai, right? Again, you take another element for the conversely. Y belongs to intersection ai. Then y belongs to ai for all I, which means y plus ai is 0 plus ai for all I, right? Which means phi y plus a1, y plus an is 0, which implies y belongs to car phi. Thus we have car phi is basically intersection ai. Okay. So by the first isomorphism theorem, this phi will induce a theta which is injective, right? So theta is a monomorphism. Now, for this condition, if r square plus ai is r for all I and ai plus aj is r for I not equal to j, then theta is an isomorphism of rings. So they are saying that this theta that you just have is also surjective once these two conditions are given. Okay. Why? Shubrita, what does this notation mean? R square plus a. This is a weird notation. What does it mean?
বুঝতে পারছি না।
Hmm. একটু দেখ তো নোটেশনটা স্পেসিফাই করা আছে কিনা নাম্বার 4 এর মতো। Please check whether the notation is specified or not. One thing, are they trying to say that AI is idempotent? Just give me a minute. Let me figure out the notation. I mean, I have been ignoring it, but সুবিধা একটু খোঁজ তো, খুঁজে পেলে আমায় বল। also looking for it. What does R square plus
दादा पेज नंबर 124 ए जाओ।
Hmm. Hmm. Now.
ওই ওই 2.5 এর যে 2
Hmm.
লাস্ট পয়েন্টটা দেখো 2.5 এর
Hmm. Along. Now what?
মানে একদম স্কেচ অফ দ্য প্রুফের
Okay.
2.5 এর যে 2 মানে
Two.
স্কেচ অফ দ্য প্রুফের
Yeah. Now what?
লাস্ট লাইন।
This one. Here.
হুম, এটা স্পেশাল কেসে
Acha. So basically, you say that R square are element which are product of elements of R, right? And
হুম
okay. So
এরকম ভাবে
probably,
ডিফাইন করলো।
hmm. So probably R square is of this form. Like this is finite sum over xy such that xy both belongs to R, right? Okay, let's see where do we need this, whether we need this criteria at all. So we have to check that this map is surjective. Okay, so let's see what they are doing. Hungerford is a very good book actually. So the canonical epimorphism induces a homomorphism of rings, blah 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 blah. Yeah, this theta. However, if the hypothesis of 2.25 are satisfied, and yes, that's what I was talking about. I mean, so you take any element in the codomain. Hmm. Any element. So there are some new members today in the class, right? I think Shritama and Madhurima, you guys are new, na? So please let me know whether you are having any problems to understand. So this is suppose an arbitrary element in codomain. Okay. Now what do you need to do? Understand. What do you want? So basically, we want to find an x belongs to R mod car phi, or maybe R mod right intersection. and x belongs to the R such that theta of x plus intersection AI, this is this, right? Right? This is what we want to find. But what is this map? What is theta of x of this? This diagram commutes, right? So this is nothing but phi of x equals to b1 plus a1, right? Because you, this is the canonical map, canonical projection map pi. Okay, so this x plus intersection. So what does pi do? Pi of x is just the canonical map. So this theta is nothing but theta compose pi of x, right? Theta compose pi is phi by the commutativity of the above triangle. So phi of x is this. What is phi of x? That is this, right? So that is, we are sort of back calculating, huh? So you want x plus ai to be bi plus ai for all I, right? That is, you want x such that x minus bi belongs to ai for all I, right? But look at this. There are guarantees. I mean, from this theorem, right, you get the guarantee that such an x exists, right? Right? Because the conditions of 2.25, these are satisfied in 2.27 as well by the ideals here. Monomorphism, and then if this is the case, this is the condition of 2.25 now. Okay, so the map is surjective. Okay, now let's move on to our problem. Let's move on to this problem. 2.25. So this is this, right? So we define, you understand that suppose ei is the ideal generated by p to the power pi to the power ki, right? So what is intersection ai? I running from 1 to n. This is the ideal, of course, generated by m, right? Thus z mod mz, as we have seen, is isomorphic to, okay, no, first we have to see whether the conditions are satisfied or not. So you have to check whether 1 z square plus ai, is it z? You have to check it. And then 2, next you have to check is that Is it Z? Okay, these two are needs to be checked. So suppose you have pi to the power ki and pj to the power kj. What is the GCD of these two? This is 1, right? The GCD is 1, no? So there exist xi and yj, maybe right, xi xj, such that xi times pi to the power ki plus xj times is 1, right? Right? But where does this element lie? This is inside ai plus aj. So 1 is inside ai plus aj. Thus ai plus aj is 1, is z. Okay, the whole ring. So condition 2 is satisfied. What was condition 1? Again, you just have to check the idea, I mean z square, the set, I hope you remember. You just have to check whether these are co-maximal or not. So this is not very tricky to check. So you can just check. Okay, so I mean you can just take any element. So for 1, this is for 2, and for 1 you can just take, see, that look at the trick, what I do. So from ai you will of course take pi to the power ki belongs to ai. But can you tell me what should I take from z square? What should be the element from z square that I should be picking? I think you just take pm to the power km into, yeah, just pm to the power an into 1. This is in z square, right? This element is in z square, na? What was the definition of r square? R square was defined to be finite sum such that x and y both belongs to r, right? So I have taken this element and this element. So this is in z square. Now you see they have GCD 1 again. I mean, of course, I mean the same m can't be equal to I, huh? So the GCD is 1 again because pi and pm are distinct primes, right? So again there exists xm xi such that pm to the power km times xm plus pi to the power ki times xi is 1, which means 1 belongs to, now you look at it, this is in z square and this element, of course this is in ai, na? So 1 belongs to z square plus ai, which means z is z square plus ai. Okay, thus what is intersection ai is m, na? So z intersection mz is isomorphic to z intersection, I mean z quotient p1 to the power k1 direct sum z quotient. Sridhama, clear? Hello.
हाँ सर.
Madhurima, clear?
हाँ.
Okay. So let's move on to the next problem. See, the natural question is, so what happens if the conditions of 2.25 are not satisfied? There should exist a map which is not surjective, right? Let's see. Okay, so I am giving you 3 to 4 minutes. Try to do this. Try to come up with an element which doesn't have a pre-image. Please see it. 3 minutes you have. আমি আবার বলছি সায়ন্তন আছে।
হ্যাঁ, ও ভালো রকম করে দিক, ওটা খুব জরুরি, খুব জরুরি। হুম হুম। আচ্ছা আচ্ছা। ঠিক আছে। হ্যাঁ, সময় হলে দুজনেই আসি, ভালো লাগবে আসলে। হ্যাঁ। আচ্ছা, হ্যাঁ। হুম হুম হুম। চলছে। থাক, ও চাপে থাকুক, চাপে থাকলেই ভালো থাকবে। অবশ্যই চাপে থাকলে ভালো থাকবে। হুম। আচ্ছা, ঠিক আছে, কাকু দেখি আশা করছি তো
Okay,
মঙ্গলবার আসবে।
so
না না না।
so clearly, I mean, you can see that a1 plus a2. This is not z, right? This is not z, na, because 1 is not inside a1 plus a2. As GCD 6, 4 is 2. So a1 plus a2 is basically 2z, the ideal generated by 2. So this condition is validated. Now what about the map? Okay, I prefer to work with this map, because I find it easier to look at. Rather than theta, I prefer to work with phi. So tell me, can you give me an element in the codomain which doesn't have a pre-image? There is an obvious element. Anyone? Anyone? There is an obvious element, na? I told you that 1 is not inside here. 1 is not in the 1 plus 2. So obvious element is this. See, I encourage your participation in the class. I mean, don't just sit there silent. So tell me. Okay, no. Oh, what the hell I'm doing? There is a pre-image of this. Just a minute. Just a minute. So there has to be an element. 1 is the pre-image of this, no? So 2. So we can do one thing. Okay, so how about 1 comma 2? 1 plus 6z comma 2 plus 4z. Yeah, this is good. Okay, so if there exists x belongs to z such that phi x, that is x plus 6z comma x plus 4z, is basically 1 plus 6z comma 2 plus 4z, then what happens? X minus 1 belongs to 6z, right? That is x is odd, right? And x minus 2 belongs to 4z, that is x is even. So which is a contradiction, huh? Okay. So let's move on to commutativity. I mean factorization in the commutativity. See, more or less, I mean, you can say that in a general manner, that sort of in our discussion of commutative rings, we try to look for rings, we try to find out rings which have the similar properties of Z. Like there is a division in Z. Okay, every ideal in Z is principally generated. Like suppose if I is an ideal in Z, we have shown that I is generated by a single element. Okay, and you can check that if suppose in Z this intersection, this is generated by this element, sorry, not this element, generated by this element LCM AB, and this ideal is generated by GCD. So we try to look for rings with similar properties. So first, how to define a division, or not a division but a factorization in an arbitrary ring. Okay. So first you have to define the notion of division. So A divides C if there exists B. So suppose in a ring R, commutative ring with unity, there exists X such that C is AX. That is natural, right? Okay. And like this may happen, right? A divides B and B divides C. Then we say A and B are associates. Okay. We will see something in a moment, just a minute. If A divides B and B divides A, then these are associates. So if A divides B, then A is, I mean, if B divides A, then B is of the form some A into say Q, and if B divides A, then A is of the form some A into P into say B. So this 2 implies A into P times A into Q, right? So you get A into APQ, right? So A into 1 minus PQ is 0. Okay. So if we add another condition, if R is an integral domain, of course A, B are taken to be non-zero. In integral domain, then we have 1 minus PQ is 0, that is PQ is 1. So P and Q are unit. So if A and B are associates in an integral domain, A is nothing but a unit times B, and vice versa. B is some unit times A. Now come back to Z. If A divides B and B divides A, what do you get? A is plus minus B, right? So plus 1 and minus 1, they are both units in Z. Divide element. Okay. Okay. See. Read till from this to this. From the here to here. Read it. Just you have 2-3 minutes. Just go through it. If I read it out, it will take more time.
আপনি যে আচ্ছা কানে আরেকবার ওষুধটা দিয়ে দিয়ে দাও, আমি শুয়ে পড়ছি বাবা, ঠিক আছে? যখন তোমরা ভালো চ্যানেল পেয়ে গেছো, তখন হবে না। পরশুদিন যে আসছে তুমি কাজ করে রাখো, কানের ভিতরে গাইবে দেবো, আশ্চর্য কথা। কি বুঝতে কি দিয়ে দেখি ঘরের ভিতরে দিয়ে দেবো। রিচ খাইলে না কেন? জলটা কিন্তু বেবিটাকে সারাদিন কথা বলো আমাদের।
Okay. মা তোমার ফোন চার্জে দিতে হলে দিয়ে যাও, আমি পরে রাত্রেবেলা দিয়ে আসবো। ওকে, সো AB associates if and only if this you understand now. If B divides A, then this is like if A divides B, then if A divides B, then B is C times A, which belong to this. Okay, so when this is an exercise, it is expected that you will do it yourself. Okay, this exercise that hidden inside the theory, you are supposed to do it on your own. I mean, of course, if you are stuck somewhere, then let me know, but at least try. Don't just believe it. Okay, so clearly the notions of irreducible and prime, these are separately given. Okay, and we will see why they are separately given. There might be rings in which an irreducible element cannot be prime, but a prime element will also always be irreducible. We will see that. So C is irreducible if C has no proper divisor. That is, if divisors of C are only associates of C. Okay. So only thing that divides C are units or its associates. Then C is called irreducible. And if P and an element is called prime, that if P divides AB, then P divides A or P divides B. Okay. Look at this example. P is an ordinary prime integer. Okay. Both P and minus P are reducible and prime in Z. Okay. Now they are taking the ring Z6, Z mod 6Z. Okay. 2 is easily seen to be a prime. Okay. However, 2 in Z6 is not irreducible. 2 in Z mod 6Z, they are claiming that it is not irreducible. Why? Because 2 can be written in terms of 2 into 4, right? This is 8 and 8 and 2 are same in Z. So this is not irreducible. Okay. But they are saying that two is prime. Okay. According to them, 2 is prime. Why? Let's see why 2 is prime. So suppose you have this is it divides A plus 6 times, let's write it here. So suppose R is Z mod 6Z and 2 plus 6, it divides A plus 6, A plus 6 to B. This is nothing but this. Okay, so 2 plus 6 is equal to, sorry, so AB plus 6 is 2 plus 6 times some C plus 6, right, which is nothing but 2C plus 6, right, which implies AB minus 2C belongs to this, right? Now So AB is of the form, so AB minus 2C is equal to 6K for some K belongs to Z, right? Which is like AB equals to 2C plus 6K, right? So AB is even, right? Which implies either A is even or B is even, which means either 2 divides A or 2 divides B. So 2 plus 6 divides A plus 6 or 2 plus 6 divides B. Okay. So 2 plus 6, this element is a prime in this R, this ring. But as you can see, this is not irreducible. Mm, Let me see how much you can do by yourself in factorization domain. Just a minute. Rings of quotients and localization. Yes, this is something we need to discuss. Formal power series. Yeah, this is also something we need to discuss. Hmm. Pretty much all of it. Okay, then we need to pick up the pace a bit. Gaussian integers and all that thing. this is easy. Do it at home. Okay, we will go through the theory thoroughly. Okay, but there are some results which I'm going to skip, and I expect you to fill those gaps as homeworks, because I mean it's impossible to go line by line and complete the syllabus. It is almost impossible. So from the next day we will start from unique factorization domain. Okay, the definition of UFD, we will start from here. Okay, that's it. I'll try to start the class at least 15-20 minutes earlier, but I was getting so many phone calls